Good afternoon. I'm delighted to be here. Thank you very much for the invitation. I hope that you'll take something away from this presentation, even if that's just a bit more understanding about some of the subject matter that I'm going to get into. And it's one of those subjects that's very hard to get away from because it's in the news a lot. You may have picked up on this 2 weeks ago, colleagues at Stirling University, where there's a Centre for Research into Information, Surveillance and Privacy, had worked with the government to create a surveillance day. It was an opportunity for members of the public to go into some of those surveillance centres around the country and see what was on the other end of those CCTV cameras we've had in this country for the last 40 years. I think we can add that to the intro video that we saw of things that our next generation of students will always have known. But the interesting thing in that space now is that the technology is evolving the way in which those solutions can be used by the authorities. Some of those seem to be quite benign applications. So imagine this scenario, that you're part of a video conference call as the external remoting into a bunch of people sat in a conference room somewhere. It'd be quite intelligent if the system could facially recognize all of the people to save the need to do introductions. And in fact, some of the camera systems now will focus on when somebody is talking, and so you would always know who you were talking to over that connection. The flip to that has been in the news in just the last week, and that's the Google Sidewalk Labs initiative that's been proposed in a 178-acre site of the Toronto waterfront. And just in the last 24 hours, there's been a news article about that scheme predicting its imminent failure. And that comes down to the fact that Sidewalk Labs and the people behind that initiative haven't done the right engagement. They've failed to address the concerns of the potential community around privacy, intellectual property rights, and from the position of the local government, the revenue share. Let's bring this back into an HE context. Our learning technology team at Durham have been part of a JISC initiative for a number of years, and in the most recent survey, there were some questions in there around student attitudes towards privacy and data. And the interesting thing in this was that students aren't as concerned with where they were as with where they weren't. And having spoken to some of the students at the Students' Union, that's really a concern that we might be looking to introduce attendance monitoring by stealth. And if you look across universities within the top selection around the world, there is form in this. Some of you might remember 5 years ago, Harvard getting a proper grilling off the Boston Globe as the local paper, when it was revealed that they had been using camera systems and facial recognition in their own lecture theatres to do attendance monitoring. They hadn't told the faculty, and they hadn't told the students. And rightly, there were a lot of very disgruntled people. The interesting thing on this slide for me is this last sentence, which is the tie-in to the future career, because a lot of Durham graduates will go on to work for firms like Deloitte. Now, close to 5 years ago, probably 4.5, Deloitte opened a new flagship building in Amsterdam. This was heralded as a blueprint. What they pioneered in this building was going to be the test bed for the next generation of office space they created around the world. And there were some really good motivations from their side as a big corporate entity with shareholders to keep pleased for doing that. Part of it was an ability to claim some very good environmental credentials. So when it opened, it was the world's most sustainable office space. It's been eclipsed by others since then, but the BREEAM rating was quite phenomenal. It was loaded with technologies. And there were some interesting partners in this project, Cisco, Philips, and others, who were working together to help make this very high-profile scheme a success. And from an end-user perspective, there were some interesting additions, things like wayfinding, using the lights to help guide you to different locations within the building. But even in this very corporate space, it's evolving rapidly. And more recently in Norway, just outside Trondheim, Lysgarden has opened, and independent commentators have identified it now as setting the global standard for office building space. Different partners in this construction. But the interesting thing here was a much greater use of real-time information to tailor the experience of those people working in that building or indeed visiting it. And they haven't rested on their laurels. Even when this building has been opened and they've started to use some of this technology, they are now very interested in bringing some of those domestic technologies into this very integrated workspace. And I know that there's a colleague here today who's going to be talking about the use of Alexa and other voice-activated devices. That's where they want to go next with this. Because why have to pick up your smartphone and control the building when you could just talk to it and get it to do what you want? So, buildings are increasingly being pitched at being at the centre of a digital transformation, and what are the impacts and the costs of this? Why were Deloitte and the other companies who are building these sorts of buildings doing it? Well, buildings are a very expensive part of corporate operations. So in general, although there's some figures here which are specific from a Cisco example in the US, 1% of your average office expenditure is spent on energy, 9% on the rent, 90% on the space and for the staff. So that's a very interesting dynamic, particularly when you're having to occupy prime space in some of the largest financial centres around the world. And then when they began to look at the usage data, they found some very interesting things, which was often more than 50% of the space that they were renting wasn't in use. Let's just put some more numbers behind it. In Paris, the average cost of a desk per year, 12,400 euros. 70% of people take at least 15 minutes to find an available meeting room. And in the same survey, they found that between 20 and 50% of booked meeting rooms weren't actually in use. Very inefficient use of very expensive space. There was a real interest in trying to find a new way of doing things. But wait, I haven't actually defined what a smart building is, so let's just explore that. It's difficult because it's an evolving area. Over the last 10 years, a lot of work has been done in this, and the definition is still evolving. In effect, there's a degree of automation that helps things work, and it allows your building facilities to be managed more efficiently. There are some definitions out there. Here's one from the Smart Buildings Institute, an organisation based in Texas, very standards driven. There are some things in here: information gathering, ability to do monitoring, collection, processing, and then a means to get that back to people in a helpful way. I quite like this one from Siemens because it touches on a softer side of the application of some of these technologies. The thing is, most occupants of buildings don't really care much about them. That's where the designers and the architects get really excited. And smart systems that might be part of some of these buildings being constructed, you can get them wrong. And if you get them wrong, you can alienate the occupants of the buildings, and these great technologies, which you've spent lots of money on, can fall into disuse or worse, get vandalized. So let's bring it back to a university context again. As part of the Durham University Digital Strategy, my colleague who's the Director of Estates has ownership of the concept of an intelligent campus. And he's got a vision to focus on 6 strategic areas. And as we build more smart buildings and begin to connect them together, that's the formation of an intelligent campus. So we're interested in things like room utilization levels. Like your universities, we probably have a traditional but inefficient model that once a year, someone with a clipboard goes around the university, opening doors, going in, seeing who's in there. Is the room booked? Is the person who has booked it, are they in there? Are there 40 people you're expecting in the class there, or is it only 20? That's not efficient. Why wasn't that 20 group in a 20-person room? All of these sorts of things. Once a year, point in time. There's a problem with that. Smart administration, cashless payments. What goes beyond cashless payments? Cashless wallets on your phone, transactions which are encoded, perhaps driven by QR codes, which are more secure, token exchange type transactions. Think about student welfare on your campuses, the ability to geofence. That's okay, that's got a limitation. What about a scenario where you haven't seen a student for a while? Okay, so maybe you could look at where their smartphone is. Well, what if that smartphone hasn't moved for a couple of days? Well, it could be that the student's gone home and forgotten their phone. Unlikely, but it could happen. But what if you could take that information about the smartphone location and information from other systems? So, if the building's got access control, has the student gone in and out of the building? Have you seen the student log on to your library systems or your VLE and begin to compound some of this data together to pick up a much more accurate picture of whether there might be a welfare issue that you'd want to send security or a member of the pastoral staff to follow up on? Opportunity in that space. Utilities. You've probably got some degree of smart utilities, metering, electronic metering in your universities, but it might not be very granular, and that then might make it quite hard to understand how one floor of a building, which might be a research institute, compares to another part. And then when you try and do your full economic costings for research purposes, then you've got some gaps in your knowledge. Think about smart communications. This is about geolocation of individuals, not just where they normally are, where are they actually now, and then do targeted messages to that group. So if you've got a problem on campus in a particular building and you're trying to evacuate people from it, you can target that message to them via different means. And final one I'll touch on the transport side, smart parking. I was talking to someone just today about the joy of trying to find a car parking space here in Leeds. I know it myself from past experience, but you may also have a similar challenge as we do on your campus, which is on the main site car park at Durham, if you turn up after 9 o'clock, it's a bit of a lottery if you'll get a car parking space, and you could well spend half an hour driving up and down all the different bits of it to try and find a space to discover there isn't one there, and then you have to go somewhere else. And 45 minutes later, you probably arrived in a grumpy and rather hot heap, having had to hike up a hill to get there, and just frustrated by the experience. Now, there's some great technologies that could improve that user experience before you get to site. You know whether the car park you normally park in is full, and you can be directed to a place that's got spaces. The key thing in all of this are three components. If you're going to do some of this stuff, it's got to be genuinely useful to the people that you're targeting to give it to. It's got to be usable. It's got to have a good UI. It's got to have a good UX. And it's got to be used. If you're going to go for all of this effort, you want to make sure that it's going to have some lifespan to it. Colleagues at JISC have done some great work in this space. And so I'd encourage you, after this event, to begin to look at some of the resources that they've made available. At the end of my presentation, I'll give you some of the links. They're using the language that will help you as an IT function to sell this into the business and get senior stakeholders to buy into some of the concepts around the intelligent campus. Because the final bit in James's comment is the bit that excites me. This almost endless possibility to add value into the organisation. Internet of Things is definitely a component in the concept of the intelligent campus. It's been called a business revolution that's enabled by technology. But there are effectively two strands to it, which I'll touch on here. There's the information technologies, these things, the ones that enhance the workplace services. And I'll just pick on one of them. Access control. Third-party engineer comes on site to service a piece of your equipment in one of your buildings. Drives on site, goes to security, gets a key. Drives across campus, parks up, goes into the building, up the stairs, into the roof space to find that the key that security have given him doesn't let him in the room. Downstairs, back into the van, drive back across the campus to security, get the different key, back, up the stairs, eventually get into the room, do the stuff, and at the end of that have to go all the way back. Meanwhile, an entire building of people have got a vital service which is important to them missing. Well, wouldn't it be different if they were using a smart card, like an ID card? Well, probably not, because you've probably got mag-stripe readers in heavy use across your campus, and effectively it'd have the same problem. If they haven't been given the right permission on the card, they'll still need to go back to security to get a card that's suitably encoded. But it would be different if you're doing near-field communications from a smartphone, because when the engineer gets to site, if they haven't got the right access, the security staff can push it to the device. And when the engineer's finished servicing it, you can revoke the access. So they don't need to go back to security to pass anything back to them, because you can control it all over the network. The other side to this are operational technologies. And here are some of the examples. I'll focus again on one of them. Does anyone understand the impact of carbon dioxide build-up within office space? Put your hands up. 1, 2, okay. So, academic colleagues, probably from your research universities, have been working in this space and have produced research which now shows that when carbon dioxide levels rise from 1,000 parts per million to 2,500 parts per million within an office environment, then you get a dramatic trail-off in the productivity of your staff. And the general pattern of this is that in an office space, when you come in the morning, it's had all night to vent the atmosphere, naturally, and so there's good oxygen content in the room, low CO2. But over the course of a day, with hundreds or so people in an open plan office, all breathing in and out, the carbon dioxide levels build up. And so towards the middle of the afternoon, you're getting into a region which is getting close to that 2,500 parts per million level, unless you've got some mechanical ventilation to kicking in. To contextualize that tail-off in performance, a 35% decrease in basic activity, a 60% reduction in the ability to use information, a 90% reduction in the ability of people to use their initiative. This is research from our universities. This isn't made-up numbers. So, all very interesting. How do we make that useful to those of us who work in support services? How can it add value? Well, here are 4 points. Wouldn't it be really nice to know what's happening on your campus at any given point in time? Just think how that could be useful to you in the delivery of the support operations you're responsible for. Wouldn't it be nice to be able to push information out without needing to send your field engineering team out onto campus to deal with a problem, to be able to remotely do it from desk? Wouldn't it be useful to be able to identify problems in failing equipment before that impact hits, and to get the engineering team or the supplier to come in and fix it before you have the impact of a loss of service? And just think about the potential of the information you could gather on how your campus is currently being used and the buildings within it to inform the design of the next generation of buildings. Some people find this hard to conceptualize, so helpfully JISC have produced a rather lengthy set of case studies, and behind each of these is a documented case study with examples. And just in the last week, I shared this with our head of library, and she had a look at some of them that we were interested in. She came back and said, well, it doesn't exactly cover the use case that I had in mind, but it was close enough for me to now understand how we could get to where we want to be. And that's given us a really good opportunity to work out the desired business outcomes in this space. How are we going to optimize service efficiencies? How are we going to track the location of assets and individuals? How are we going to offer an improved care for our students and improve customer service? You're going to need to start thinking about some of the components that make up smart buildings and intelligent campus. And you'll have many of these things already. Virtual learning environments, estate management systems, student record systems. You might be doing some sort of attendance monitoring. You might have a timetabling system which has got API integrations that you can do stuff with. You've probably got some idea on space utilization, but as I said before, it might not be very accurate. And you might be doing some form of energy monitoring, but might not be very granular. Where organisations are probably reaching out to your estates department and IT function is in this middle ground, because it's the ability to gather all of these connection information sources and process the data, which is where the real challenge lies. Because some of this stuff was never designed with that in mind. And so there are aggregation specialists, firms like Arrow and Tech Data, who are now global leading in helping you get data out of your Schneider and Bosch building management systems and sensors and into some central place, which might be an Azure Internet of Things environment. It's a capability to process information and transform it in some way, and then present it and visualize it and make it available to people. Now, some of that presentation may be hidden. It's automated. The building knows, it knows you as an individual, or it just knows how to handle itself, as with the carbon dioxide potentially triggering a window actuator to open so the building naturally degasses and gets that carbon dioxide out. But it could also be at a very micro level. So iPhone 10 has 4 microelectrical mechanical system, MEMS. These are tiny little devices. It's got 4 of those just as microphones, and a whole lot more around the accelerometers and other devices that are built into it. And potentially all of those could be harnessed to gather information and feed in. Are you beginning to see a problem with some of this? Some of it it's difficult to do, and it's difficult to do in retrofit, or your opportunity doesn't come along very often. So your fire alarm system, probably good 10, 15 years before you'd think about changing it. You're waiting potentially a long time for that opportunity to come around. Air conditioning systems, that might be 20 years. Other things are a bit easier. I know of schools in County Durham that put in the latest generation of energy-saving lighting, and then 2 years later rips it all out to put in the next generation of energy-saving lighting, because they'd done the economics behind it and worked out that in a very short space of time it would have paid for that new fit-out. Gartner have said that the biggest challenge for those of us working in the IT function is that we probably don't have the right skills in our teams to be able to pick this up and support it at an institutional level. And that your CIOs and IT directors are going to need to think about what skills that they have to be able to do some of this stuff in future. A big challenge that we've got in most estates is that because this stuff was installed almost organically with that much thinking for this eventuality over time, it's become quite siloed. And building performance evaluation studies conducted by those people who work in the estates function have identified that even those systems supposed to be capable of being managed by the central building management system aren't. And they're actually controlled by standalone vendor systems. And the software systems that sit behind them are incompatible with other systems or talking to anything else that's run more centrally. But here's the other gotcha. You've got to be thinking about the end-to-end security on some of this stuff. And the problem is, it's probably already in there and it's a risk for your organization. It was identified as a more immediate security risk than consumer tech 5 years ago, and we've probably kept putting it in every year since then. The devices tend to lack built-in security capability, so you have got some big problems for you. And if those of you who keep an eye on the press, you might remember Target in the US. They were hacked through their air conditioning system in one of their 55,000 outlets. And through that hack, the personal details of 40 million credit and debit card details were stolen. Okay? That's some of the risks that you're facing if you haven't got the security side of this bottomed out. So, put that to one side, let's think more positively. We're building some new buildings on campus. We are, you probably are as well at some level in your estate. This colourful diagram represents the Royal Institute of British Architects, RIBA, process for building a building from inception through to here are the keys, it's all yours. And almost all universities that I know of will follow this process. It's quite industry standard. You need to be thinking about commissioning the systems before you think about building the building, because the cost of trying to retrofit some of this smart tech in exponentially increases the later you leave it. You've got to get in there at the start. And you've got to be careful that your colleagues within the estates function aren't signing you up to subcontracted package deals, which will then limit you and your ability to extract data and do interesting things with it. Right, I've talked quite a bit. You've just had lunch. Let's try and enlighten you with a friendly American voice.
Imagine a service that senses my phone or license plate and connects me to an app that directs me to an available parking spot or a charging station if I'm driving a smart car. Outside the building, moisture sensors ensure that the irrigation is used only when needed, and smart weather analytics determine if it's worth waiting for the likelihood of rain. When entering the building, biometrics recognize me and let me through security. My app will show me where a free space to work is, or in today's case, where my meeting is in the conference room in 5 minutes. It'll even show me the fastest route there. Oh, and look, the app knows I have time for my caffeine fix. So here's my conference room. It's equipped with smart features like this wireless charging table. And this smart wireless display lets everyone share their screen, even if they're not here, for easier collaboration. Throughout the building, heating, lighting, and cooling are utilized more intelligently. And we can rate our comfort level so the building learns how to continuously improve our workplace experience. It can also improve my dining experience. My app shows me what's on the menu today. I can pre-order and avoid all the lines. And there's no need for me to pay here because my credits are auto-deducted when I order. Need some IT supplies? No problem. With these smart supply dispensers, I can quickly get what I want, and my department is automatically billed. The on-campus fitness center connects with my smartwatch to track my progress, but that'll have to wait because I have a lot more to show you. Hey, we've only scratched the surface of what's possible in tomorrow's smart buildings, and many of these technologies are already in use today. What makes it possible? It starts with data, sensor data, contextual data, data we enter, and more. The data is transmitted to the data center or cloud, where it's analyzed and transformed into actionable insight. Smart building applications built on the open, secure, scalable, and manageable Intel Internet of Things, or IoT platform, use that insight to respond, adapt, and optimize. The result? We're more comfortable and productive, and building operations become smarter and more efficient. Smarter than if components were isolated like today. Smart buildings, they're here, they're awesome, and we're going to ensure they just keep getting smarter.
It wouldn't be a good American video if they hadn't got the word awesome in there somewhere. Right, so hopefully you can begin to think from that video about how some of that stuff might work in your university context. I showed this to my CIO yesterday. He got very excited. And it was quite nice to say, well, we're doing that, and we're doing that, and we're doing that. But what we don't have at the moment is the ability to join it all up and create that warm and fuzzy ecosystem that people might benefit from. So what I'm going to do in the remainder of my time is just focus on a couple of use cases to help you get your head around some of this technology in a bit more detail. So I'm going to start with lighting. The data from UK schools indicates that for a school which has got less than 2,000 square meters, they're consuming about 15 kilowatt hours per square meter a year. But when that size of the school goes up to more than 8,000 meters squared, they're consuming 30 kilowatt hours per year, per meter squared. And there's a very interesting relationship between size and lighting and this dynamic. So although there's an ability to save money with the installation of some of these technologies, the other benefits that might drive your organization to change are actually about improving the welfare of the people working in the space. How can we use some of the new technology and its smart capability to offer a more personalized experience? So not everyone wants the same lighting recipe. So give them the ability to tailor it. If you've got a well thought out building, the light's literally above the person's desk. And a bit like being on an aeroplane, you can control your little bit of the world by adjusting that lighting experience. As you move forwards, back to the example of 12,400 euros a year for a desk in Paris, well, Deloitte have just sliced a big chunk of that off through their deployment of the Edge as a blueprint. And in India, Intel, who you've just seen the video from, have decided that the best way to manage the lighting is make it somebody else's problem. And they've got lighting as a service. And the great thing about this is that the need to fine-tune the systems and tailor it, so if Intel change and reconfigure the supply line, they just phone up the lighting supplier and say, well, you need to come in and reconstruct the ceiling and give us the appropriate lighting for that space. I think that the big thing in this, if you're thinking about going down this way, is you've got to think about how are we going to support this in operation? Are we going to be dependent on a technician coming on site with a laptop, plugging it in to reconfigure the system? Or are we going to empower our own staff of engineers? Or are we going to outsource that capability? From an operational point of view, whether lighting will be your responsibility as the IT function in a smart-enabled concept or that of your colleagues in estates, the ability to understand the lighting across the estate, it will be useful to them. In the same way as if it was an IT component, if it's broken, let's know about it so we can send someone to fix it. And if we can tell that that light has reached 90% of its consumed lifespan, let's go and proactively replace it before it breaks. So, convergence. I mentioned convergence earlier in my talk. I've brought a prop. This is an RJ45 cable. Many of you will have one of these in the office, or perhaps one or two of them. These RJ45 cables are now replacing all of these traditional technologies in a smart enabled building because you're connecting things all together over this cabling technology. And the latest Cat6A standard cables, which would you expect to be going into any new build, will also support the latest increases in power over Ethernet, which will allow an entire ceiling, twice the size of this one, to be run off one RJ45 socket with appropriate LED luminaires attached. The advantages of some of this smart tech are significant cost savings in the traditional approach to installing new technologies in your campuses, as Purdue found with their ability to dramatically reduce the cost of installing their next generation of wireless access points. Bob Allen and Simon, I should explain that. Simon are a major supplier of the cables. Not so big in the UK, but a big player in the US and mainland Europe. So convergence allows you to do some quite interesting things. Here is an example from Durham of our current flagship teaching and learning centre, the Calman Learning Centre. Last year we opened that, having waited 10 years to refresh it. It's gone fully network AV. And the advantages that that has given us is the ability to present audio and visual throughout the building in a way that we couldn't before. The real thing that it has given us is an opportunity to prove the technology before we build the next big thing. And this year, the new Teaching and Learning Centre at Durham opens, significantly bigger than the Calman. This will be the new flagship. When we designed this, it would have been the largest in Europe. I think we've probably been surpassed by another one now. AMX is our AV control system. It's their SVI system which encodes the data at either end and shunts the traffic across the network. But it's given us a matrix within the building. So as our colleagues within the Durham Centre for Academic Development enhance the way in which people are teaching our students, we can reconfigure the rooms much more easily because we've got network access points on the wall, and we can literally go and mount a monitor or a screen in front of that network access point, and with configuration on the network, we've got that part of the AV estate either in the room or the building. And our ability is now to extend this throughout the campus. When we were designing the Teaching and Learning Centre, one of the things that we were very interested in was how the building would be used on the hour changeover, because there's a lot of people in here coming in and going out, and we wanted to be confident that as we were designing it, we'd made the atrium and the corridor spaces big enough. The other advantage this gave us was to have some really useful data to go back to our wireless partner and said, well, these are the heat maps that we expect for this building. We want you to make sure that as the students come out of their lectures, they can get straight onto Snapchat and Instagram and whatever, and have good network connectivity in the building without it impacting on the educational systems that people might need to actually do the educational side of things. So they've produced this visualization that you can see here, and it shows it for each of the floors within the building. And the interesting thing in this, and it was the team at Burrow Happold Engineering who created this visualization for us, is what we now want to do is test the accuracy of the forecast against the reality when that building opens in September. So what we're really getting into is the concept of space utilization. I've gone full circle back to that very awkward process, person with the clipboard. Okay, can we find another way to see real-time use of that space? The technology exists to be very accurate in this space. Our platform of choice is Sky-Fi for wireless analytics. Think back to the dots that were moving about before. We could look in some of those rooms and see if it's been laid out cabaret style, or linear, facing the front, and we can begin to see how people are using some of those flexible learning spaces. And we can begin to see, is it time to start putting more of those flexible spaces in as we refurbish our estate moving forwards. Some really interesting opportunities here to look at how long people are staying in places, and in this example of our chemistry building, how they move through the building from one place to another. And just think that with each of those steps you can see how long a particular contingent of students stayed in one place. You can do that both live, and you can look back at a track record of data, and then you can begin to plug this data into that central aggregation point, layer in information from the other systems, and find a way to put some useful outputs out to decision makers within the organisation. Similarly, this is some heat map stuff. It shows you the potential bottlenecks and congested areas within our library. I haven't done an animation here, but as I cycle through, you begin to see that picture changes with time. I'm conscious I'm probably running a bit late. I'll move into the conclusion. I think I'd like you to think about these few points as a conclusion to my presentation. The future is definitely more networked. Wireless will play a part, but you're still going to need lots of copper and fibre optic cables running through your buildings and the ability to join them up. What you're delivering to your universities is a more agile estate that can react to the changing demands of academic and research colleagues, and your ability to configure it. It will give you a source of data to inform your designs. You'll definitely be more connected, but you've got to think about the security aspect that goes with it. And all of us, I'm sure, would much prefer to better understand our campus, because if we better understand it, we'll be able to better support it. If we can master the intelligent campus, we can be more ready for the unexpected most of the time. Thank you. As I said, here are some great resources for you to follow up on this talk. These are from JISC. I think my presentation will be made available. Happy to answer any questions that anybody has if there's time. Okay, I'll be available over coffee if anyone wants to grab me then.